Hello everyone, welcome back to our Grasshopper tutorial. Today we're going to talk about how to model this Olympic Cauldron in Grasshopper. And first, let's look at the clip. So you can see that the math behind this is just absolutely beautiful. And let's see how we do this in Grasshopper. This is the final result of my simulation. And then we can change all kind of different parameters of this whole shape. It's 100% parametric. We can change the density. We can change the count of how many those little shiny pieces in between. We can even change the complexity by changing their rotation periodic number. This looks extremely complex, but actually the logic behind it is very, very simple. And now let's begin. Make a new file. And first thing first, we need to draw a circle. And how do we do that? We're going to come over here to curve and find this component called circle. And when you draw a circle, of course, you want to have a center for the circle and the radius. So we'll do the center. Just let's use the origin, which is the world XY. And let's use the radius. Let's just do 33. I usually type in 33, 22, 11, or 1111 just because it's easy. Okay, it's just type in 1111 or 33. Next thing we will do is we will use this component called perpendicular frames. So the logic behind this one is very simple. So basically they're going to make a bunch of equally spaced plane, and the z direction of this plane is the tangent at that specific point of that curve. Okay, so we can use default 10, we can make like 100, or let's do 50. If you want to make this plane bigger so you can see it easier, we can come over here to display and find preview plane size. We can change it to 3 and then hit enter. Okay, so now you see it much clearly. The next thing I'm going to do is going to draw a bunch of circles on this plane. Just use this one again and draw some circles and make it bigger. Let's just do 33 again. So the component circle is going to create circle defined by the base plane and the radius. And the base plane right now are perpendicular to the tangent value at the point of this curve. So when they are drawing specific curve or specific circle on this plane, those circle will also be perpendicular to the tangent value at the local points of this curve. So the next thing I will do is I will actually find specific points on this circle. Now let's find the starting point. So I will come over here and find the starting point and the ending point by using this component called endpoints. Extract the endpoints of a curve. And then let's find the start points here. Right now, because it's a circle, so the starting point is the ending point. So it doesn't matter which one you take, let's take the start point. And then the next thing I will do is I will come over here to curve. There's a specific tool here called point on curve. What this does is that it will simply find the specific point on a curve based on the input value. If I put in 0.5, it will find the center point. So this value has nothing to do with the length of this curve. They just divide the curve into 0 to 1. And then this input 0.5 just means the center of the curve, right? So we find the start, we find the center, and then if we connect them together, we will see a bunch of lines, right? And now we can hide those circles that we just draw. We just get a bunch of lines like this. And now you're going to ask me why we cannot just draw some lines, why we need this circle. Well, you will see that in a little bit. And also this radius, it doesn't have to be 33. Actually, it should be smaller than 33. Now let's just change it to 28. The next thing I will do is I will just ask those lines to rotate based on this plan. Very straightforward, right? So I will come over here and then I will choose rotate. And then for this component, the inputs are the geometry, which are those lines, the rotating angle, which is default 90 degree, and then the plane. It's default world plane, but I don't want the world plane. I want them to rotate on those planes. So I'll bring the planes here. Okay, so they automatically rotate 90 degree. And now I'm going to hide this one too. And then I will also give it an input for the rotation angle. Okay, so I will type in radians. As we talked about before, they only take radians here. We want to put degrees because I'm a degree guy. Okay, so I will just do 90 degree. Let's do 90 first, and then we'll plug it in. And now if we do this, okay, start to have this kind of effects. Now let's make it bigger. Let's make it like 1,000 or 2,000. How about that? And now we are making this kind of movement, right? But it's still different from what we have seen inside of the video. Why is that? That's because in the video, each of those lines are not on the same plane. Right now, they are all on the same 2D plane, right? If we make it to 0 degree. So, for example, in that sculpture, when this member here is 0 degree, right? And then this one is actually, let's say 2 degree, and this one is 4 degree. So basically they are not on the same plane, and we need to give this rotation at the beginning also. So how are we going to do that? We're going to give it a series, right? We talked about this before. Let's give it a series. And how many numbers we want to have? Well, now we divide this curve into 50 segments or 50 planes. So we want 50 values for those rotation angles. I'll just plug this 50 to this series count, right? We talked about this components many times. And now we're going to bring these numbers into the degree input. Now you can see that it starts to rotate, but the end points or the end pieces, this one and this one, they are not aligned. Why is that? Well, the reason is pretty simple. Let's look at the series number output. It's 0 to 49, okay? Clearly, if we want to align them once they finish a rotation, it's at least to be 180 degree, right? Because if we want to rotate it for a full circle, it's 360. Right now, they are curves, they are symmetrical along this axis, the green axis, their left and right is symmetrical. So it doesn't have to be a 360 degree in order to make this line right here align with this line. So what I will do is I will make sure that ending point or the last digit will be 180 degree instead of 49 degree. How are we going to do that? Well, let's do this. We have to change the steps. So, and we have 50 number inputs right now. So what we need to do is 180 divided by 50. And then we will get 3.6. Let's see. Whoa. Once we change the step to 3.6, the last one is 176.4. Well, it's actually what we want. Why is that? Because we don't want them to be completely flat, but rather to have this smooth transition in between. So this is the answer we want. Now let's rotate this and let's see what's going to happen. We can simply rotating this by changing the starting value of this number series, right? We can just type in 111 and plug it in here. Highlight this and then change it. Now you can see that it's coming along very good and getting close to what we have seen before, right? Well, the next thing I want to do is actually I want to make it a little bit more interesting. How about we make it more than 180 degree, but rather 360 degree, right? We can change that by typing here 360. And let's rotate it again, highlight it, and then rotate it. See, it's getting super interesting. And we can keep changing. Let's do 720. Highlight this again and keep rotating. And let's say I'm sick of highlighting those things and I just want to give it a color, a constant color. What I do custom preview, and I will select this, which will take the input and give it a color. And then I will change the material. The default one is this little purple thing, which I don't like. So I just can select my favorite color by using this thing called color picker. Okay. And I'll come over here and I'll just change saturation. And yeah, let's see if this is good enough. Okay, well, this is very close to my favorite color, which is very similar to Tiffany blue. And I will just go with this. The next thing I will do is I will make those lines thicker. And okay, so we can see this. Now I can hide many of those lines, right? I can just simply hide them. And then let's play with it. See, I am rotating it by changing the starting points of this number series. Why is that? Again, because the steps are set and also the counts are 100. They are set too. All I need to do is I change the starting point. So the series will start to change. So the degrees will start to add up and finally reflecting on this rotation component. The next thing I want to do is actually I want to go back to 180 degree. And then if I want to make it easier to get 180 or 360 or 720, we can simply just give it a multiplication. I would do multiplication here. And I would do, let's say 3. Plug it in. Bang, we got it. So we don't have to type it in here every time. Let's go back to 180, which is a degree that they have been used before. And now you're going to say that, oh, wow, this doesn't look like what they have done at all. Why is that? It's because instead of have one line, they actually have 2 lines in each plane, right? The plane is a little red thing. Right now, we only have a curve on this direction. The final result also have a curve on this direction too, okay? So those 2 are perpendicular to each other. What we need to do is actually we need to rotate those curves 90 degrees and keep both of them. How are we going to do that? Well, there are many ways, but I want to introduce a way that's going to make the data structure super clean. And also you can use some knowledge that we have learned from the previous tutorials, specifically for the data tree or the list and nested lists part. So let's begin. Do you remember we draw those circles a long time ago, right? We find the starting point and its midpoint to make those curves. How about we find the quarter points like 0.25 and 0.75 and make the lines based on those 2. Let's do that. And let's see. Let's do 0.25 and let's do 0.75. And let's connect them together. And let's plug it in. Remember, if you want to have multiple inputs for this component, you have to hold Shift and then drag it out, okay? And then you'll be like, whoa, what's going on? Why it's doing that? Okay, let me explain to you why. So let's read the data for those 2. Okay, so now we have a list. This list has 200 data. And let's look at the data from this input for the angles. Now it has only 100 data. And for the planes, same, it has 100 data. We can read here, 100 values inherited from one source. Okay, so this goes back all the way to what we have learned before. Now we are trying to make sure that this list applies to this, okay? So how are we going to solve that? Let's start doing this. And first, let's log this, because if we connect something wrong, and the mapping rule will make this thing so messy. So let's first graph this. We explained what is graphed before, and let's graph this one too. And let's pull up this thing called merge. We will plug this one in, plug this one in, and then connect them together here. And also, I will graph this one and graph this one too. And then let's open it up. Now this is what we want. It looks like there are some reddish stuff here. It's because we added them here and then let's hide them. Okay, so let's start to rotating them again. Well, I can assure you that this is exactly the logic behind the Cauldron in the Olympic Games. Okay, now you are asking me that what we have done here, why we need to graph this and why we need to graph this and why we have to graph this. Well, let me explain to you. So before graphing the data, it's one list with 100 data inside. And then after we graphed it, let's just put it here, take graphed, and look at it. After we graphed it, it's 100 list, and each list has 1 data inside, right? And then same for the plane input. Before we graphed it, it's 1 list with 100 data, and after we graphed it, it's 100 list, and each one have 1 data inside of the list. The next thing is tricky. We come over here, we read this thing called merge. Merge a bunch of data streams. Let's forget about the bunch of data streams. Let's just look at what they have done here. After we graph these lines here, we got 100 lists, and each list has 1 item inside. Same as this one. Okay, so after we merge them, let's see what's going to happen. You see, this is one of the original list, which contains 100 lines, which we connect the start point of those curves to the midpoint, right? Those are the lines we got first. And then those 100 lines are connecting the 0.25, which is a quarter points, and the other quarter points. Now we grafted it and make them 100 lists, which every list has one item inside. And then we use this merge thing. We put them together one by one. Let's say this item here. Oh, we have a line here. And then we use this thing called merge. What the merge did is that they joined the two lists together. And then they will put all the items which has the same list index all together. This thing 0099, they call it path, right? Actually, just an index for the lists within the list. So if they see that, oh, this index is 0099, well, I will throw this item together with this item because they have the same index. And then we will get this new list. And now everything can be explained together. We got the new list, which has 100 lists, and each list has 2 lines. And then we got this one. These ones, they are the rotation plan, right? The center of the rotation. They are those little plans here. Originally, it's one list with 100 plans inside. But right now, it's one list with 100 lists inside, and each list has one plan inside. And same as this one. Originally, we have one list have 100 different rotation angles, and now we have 100 lists, and each list have one of those rotation numbers, and then they are all equal now. You see, this is 100 list, this is 100 list, and this is also 100 list. So we can forget about the number 100. We can just look at one list, what's going to happen. Okay, let's pull up to the last list. It's 0099. Okay, in this list, we got 2 lines here. Okay, this is what we got. And now let's look at this list here. The item on this last list is one rotation center, which is the plan. And then let's look at the last list of this rotation angles, right? In this list, there's one angle, which is 20.14459. So they are all connecting to each other one by one within these lists. So in these lists, those 2 items will rotate based on this rotation plan. And then the angle will be this angle. Okay, same as every list in the rest of the whole data. We can now just forget about those data structure. They are not important anymore. All we have to focus are those ones right here, 2, 3. Okay, within each of the lists, no matter how many items are in these lists, right? Now there are 2. Let's say there are 5. They were rotating based on this specific data under the same group name, which is 0097, right? With the same rotation degree, which is 20.081758. Okay, now it makes sense. That's why we have to maintain the data structure here. And if we ignore the data structure and let's just simply not graph it, this is what's going to happen. See? And why is this happening? Let's look at the data for the rotation plans. You see, we graphed the rotation plans here. We got one list and have 100 lists inside of this list, right? And if we just simply ignore that, we just delete this, what we left over is one list, and this list has 100 items, which is 100 plans inside. And now what's going to happen is the following. This is the lines that we are trying to rotate. This is the angles that we have been used. And this is the plans that they are rotating. The program will start to run. Let's look at the last list, okay? We have 2 items in this last list, which are 2 lines. And then this lines is going to start to rotating itself. The first thing they will do is they will search the angle. Because we grafted the angle, we will come over here, okay? We will say, you two rotate 20.144 degree. Okay, makes sense. Oh, by the way, they are not degrees. Those are radians. My bad. So this is a radian value that those 2 will rotate based on. And then the next thing they were trying to do is they were trying to find the plan they are trying to rotate based on. And then they find one list which has 100 items. So how are they going to connect to each other? Well, we talked about this before in the previous data structure course. Let's say we have 2 items here on the left, 1, 2. And then we have 100 items on the right, which is all the way to the 100. What they're going to do is they will connect in this way. They will connect the first item on the left to the first item on the right. And then they will connect all the things left on the right to the one item on the left. So this is what they're going to do. So they will rotate the first line based on the first plan on this list, which we cannot see right now. And then they will rotate this line right here 99 times. Okay, because we have 99 rotating plans here, just those ones here. That's why I say the mapping law is very important in Grasshopper, or this connection law, or the way of connecting, whatever. But again, all the angles they are referring to are the same, is this last digit on this last list. And hopefully this explains everything. But if you don't understand it, you can always come back to me and I will explain to you all over again. Okay, so I'll clear all the drawings. And that's why the graph is so important, to maintain this group to group or list to list, item to item relationship. So I will graph it back and solve every problem. Okay, the left things are not that important. What I will do is just make it simple, copy, drag it here, and then plug it in. I can change it to, let's say 5. Okay, so basically I find a bunch of plans on those curves, and then I'll just draw some circle on it. Let's hide everything. And again, I will give it a color by dragging those things to the geometry. I can change the color to the thing that's closer to the real Olympic Games, right? These golden ones. And then again, I can play with the start value to have this rotating effects. And if I want to make it more complicated, I can change it to 2 or 3, right? And then I can just keep rotating. Okay, that's it. That's what we're going to talk about today for this sculpture. Of course, you can add all the details into it. For example, this actually, they are not circles, they are spheres. And the top ones, they are circle. And you can add all kind of details into it. We once again explained why the list and nested lists are important, why we have to graph things, and why we have to make sure that they have this list structure. Again, we have to keep those list structure because we want to operate them on those lists and make sure that those complicated data will find the specific data they need to use in this list structure. Thank you so much, and I'm looking forward to see you in the next tutorial.